We now want to take a look at how to become a little more mathematically rigorous in determining the strength of a relationship. Now, a caveat that we're going to take a look at is we're specifically only looking at linear relationships in this section. Okay? We know and understand the reality that other types of relationships exist, but we're specifically looking at linear relationships, especially when we're taking a look at what is called, that we're going to be able to calculate here, the correlation coefficient. Okay? Notice it says this is the linear correlation coefficient. Okay? Now, we've got some examples here. We're going to define what it is, and then we're going to see how to calculate it. Okay? We can see that we have 3 different positive relationships and 3 different negative relationships. If we look over here, it says the correlation coefficient is unitless, and then here's a key piece. It's always between -1 and +1. Okay? That's a key piece. 0 means that there is absolutely no correlation, no relationship between the 2 variables. Okay? The closer you get to +1 and -1, the stronger the relationship becomes. But what you'll notice here is that, for instance, if we have a correlation of r equals 0.5, you can see that there's starting to form visually a relationship, a positive linear relationship. But notice as r gets bigger, closer to 1, that relationship gets stronger and stronger until at 1, it's a perfect linear relationship. The same is true as you look the other way. At -0.5, you can see that there's starting to become a negative linear relationship. You get to -0.9 and the negative linear relationship is pretty strong. And then at -1, it's a perfect negative relationship, linear relationship. And so both -1 and +1, they both signify strong or perfect relationship, but just one is a positive relationship. It's growing from left to right as opposed to a negative relationship. It's shrinking from left to right. And so we want to be able to take a data set of x and y values and calculate this value r. What is that value of r? Because I want to see, is that value of r close to positive or -1, indicating that there's a strong correlation. So how do we do that? Well, here's the formula. I know this looks nasty. However, there's a couple things that we can glean from this, that it looks a little bit nastier than it actually is. Okay, so here's what we're going to do. What we're first going to notice is here is just the sum of x's. Here's the sum of y's. Now, that's pretty easy. I can just add those columns up. Here's the sum of x times y. Okay, so I know I need to do an x times a y. Okay. Down below, notice I have an x squared. And I also have a y squared. So those are 2 other things that I end up needing to be able to calculate, x squared and y squared. Okay. Very good. So how do I work through this? Know that you can actually work through this in Excel as well, if that's the way you prefer to do it. But I've got 6 data points here, so we're just going to work through it by hand. Once I know these pieces, I can start summing things together, finding the sums of each of these columns. Okay. And, excuse me. And then from that perspective, plug everything into the formula here that I know. And then simplify from there. Okay. So 63, 29, 20.8, 19.1, 13.4, and 8.5. I'm going to do a quick sum of that. Oh, I made a mistake in my calculator. So I'm going to start over really quick. I'm going to say equals Okay, I'm getting 153.8. Go ahead and do that yourself as well as you're following along in the video to make sure that you're getting those answers. And then I know I have 7, 3.9, 2.1, 2.8, 1.4, and 1.5. And I'm going to go ahead and sum that as well. And when I add all that up together, I'm getting 18.7. I did that because I know that in this location and this location, I have to sum those up. Well, now what about the x times y? Okay. Well, if I go through, multiply each x times y, let me do that first one really quick. If I do the 63 times the 7, that gives me 441. Okay. Now, what if I go ahead and do that to all of those? Let me write these down really quick. I've done them. 29 times 3.9 is 113.1. Now, 20.8 times 2.1 gives me a 43.68. My 19.1 times 2.8 gives me a 53.48, and then the last two values here are an 18.76 and a 12.75. And then what I'm going to go ahead and do is I'm going to sum that up as well. Okay? And when I add all of that up, I end up with a 682.77. Because I know I've got my sum symbol here. I'm supposed to sum all of the values of x times y. Well, let's go ahead and do the same exact thing with my x squareds and my y squares. So I'm going to calculate these really quick and then write them down. And like I said, you follow along too to make sure that you're getting similar values. Okay, so the values I'm getting for my x squared is 3969, 841, 432.64, 364.81, 179.56, and 72.27. Oh, sorry, 25. And I'm going to sum all that up together, and that gives me 5,859.26. And then I do the same thing with my y values. So 49, 15.21, 4.41, 7.84, 1.96, and 2.25 for a sum of 80.64. So again, this is just taking my y variable, squaring it, and then summing it up. Believe it or not, I now have everything I need to be able to just plug into this formula and solve for r. So let's walk through this. In my numerator, what do I have? N. N is the number of values, number of data pairs. 1, 2, 3, 4, 5, 6. So I'm going to do 6 times the sum of xy. That's this column right here. So that's 682.77 minus the sum of x, which is 153.8, times the sum of y, which is my 18.7. Good. And I'm going to divide that by the square root, okay, the square root of, so it looks like in brackets, I've got n again, so that's the 6, times the sum of x squared. My sum of x squared is 5,859.26, okay, minus the sum of x squared. Notice the square is on the outside. So I'm taking the sum of x, which is 153.8, and I'm squaring it. Close the bracket. And this is going to be multiplied by, notice I have two separate brackets underneath my square root. This is going to be multiplied by n, which is our 6 again, times the sum of y squared. Okay, here's my sum of y squared, my 80.64, minus the sum of y squared. So the sum of y, that's my 18.7, and we're squaring that and closing that off. Awesome. Okay, so we are now in a scenario where we've got everything plugged in. Now we just need to calculate. Okay, so I'm going to work through this. We're going to bring this down here, and I'm going to do it in a couple steps to make sure that I don't make any major mistakes. So I'm going to go ahead and do my 6 times 682.77. Okay, and then I'm going to subtract from that 153.8 times my 18.7. My numerator, I end up with 1,220.56 divided by the square root, and I'm going to do each of these pieces separately. Okay, just to make sure I'm not making any just simple mathematical mistakes. So I'm going to go do my 6 times 5859.62, 0.26, minus my 153.8 squared. And for that value, I am getting, back to red here, 11,501.12. And that's going to get multiplied by the other half over here. So that's going to be a 6 times 80.64. 6 times 80.64 minus my 187. I'm sorry, my 18.7 squared. 134.15. Great. So now what I'm going to do is I'm going to go ahead and do this multiplication and the square root down here. So I'm going to do the square root of 11,501.12 times 134.15. Okay, and I'm getting a value. I've still got my 1,220.56 in the numerator. I'm getting a value of 1,242.13. Last step is to actually do that division. 1,220.56 divided by my 1,242.13. And when I do that, I get a value of 0.98. So let's pause. That was a lot of math, but again, you just follow that pattern and you'll arrive. We knew we were supposed to get a number between 0 and or -1 and +1, which we did. We got it really close to +1, which indicates two things. Number one, it's a positive relationship, and it's a very strong positive relationship. So this is a mathematical way for us to be able to calculate how, and using this as kind of our guide of how strong of a correlation there is between two variables.